Hello guys, Fru here. Welcome to the channel. In today's video, we are going to talk about functional programming. Now, functional programming is something that's growing in popularity. A lot of languages are picking up on it, and there are people who might have come in from a programming background which was more procedural oriented, and it makes a lot of sense for people. And if you introduce the concept of functional programming, it could be very confusing for many folks. So what I'm going to do here is going to be a soft introduction to functional programming, step by step, really focused on making it easy so you can understand what functional programming is and have the tools or the basic understandings to go out and to learn more or to write your own functional programming code. It's very fascinating if you get a hand of it, and it becomes really exciting. Python does functional programming. Scala does it. Java does it, and many different languages do functional programming. So let's dive right into what we're gonna cover in today's walkthrough, in today's presentation. So my goal is to talk about what functional programming is, and we're gonna see this whole idea of functions being first-class citizens with functional programming. And then we're going to look at creating some Lambda expressions. And then we're going to dive in and touch on some key concepts with functional programming like map, filter, reduce. These are requirements. If you're going to do functional programming, sooner or later you run across this. And for a lot of people, it's confusing. What is a map? What's a filter? What's a reduce? What do you mean a function is a first class citizen? These are the things we're gonna touch. And by the end, if someone gives you a functional code, hopefully you will be able to understand what it is. Now, I just have to put a caveat that the topic we're touching here is, think about there is an ocean and there are waves, and we're kind of swimming on the waves. But deep down, there is way more, like, or an iceberg is, I think, is a better analogy. So there are concepts that we're not going to touch necessarily here, like monads or true functions, category theory, and more, which are the underpinnings for functional programming. I have to submit that a lot of people can write functional programming code without this background, this theoretical background. But if you're ambitious and you really want to go one level, two, three levels deeper, then understanding what monads are, true functions, category theory, which comes from a mathematics background, would be something that you definitely want to pick up on. There are books on this. I'm going to leave a couple of books in the comment section. So anyone who wants to really go deep, you can go into these books. But my submission is that a lot of people who hear about monads and category theories, they get intimidated by functional programming. And what we get left with is people don't pick up functional programming because the theory might be very intimidating. Um, but hopefully, going through this exercise in this presentation, in this lecture, would demystify this for a lot of folks. So um, now the prerequisites are, you comfortable with Python? So we're going to skip through some basic things and build on the principles that will focus on functional programming. So that said, let's dive right into the very first piece of the exercises today, and we're gonna just go right ahead and define a function. A lot of things. It's something that many people uh, would do that already work with Python, right? We know how to create functions in Python. So let's just go ahead and create a function here, a very simple function that tells greetings, right? So greetings from through. So just keeping it really basic. So we have a function, nothing to write home about. And we know how we can invoke that function. We can go ahead and call that function. So I'm defining a function. That function simply prints a name. Let's go ahead and remove that space. It simply prints a name. I can go in and I can call that function. And if we run this, we should see a result here. So greetings from through is what we see. All fine and good. We know how to create functions in Python. Okay, so this is a function. What makes a function a functional programming? And this is where we're going to start touching on some concepts here that are a little bit unique. Now, before we dive in, I just want to call out that functional programming is not a new software, it's not a new tool. is just a programming methodology. It's just how you choose to program that makes functional programming. So it's not a new language you have to go learn. If you already know Python, you can choose to program in functional programming, or you can choose to program in procedural programming. And I'm going to highlight those as we go through here in the lecture. All right, so we have a function, and that function prints out something on the screen. We can call the function, and it's going to give us a result. Now, what's interesting about functional programming is we can pass functions as almost passing variables. So if you think about a word in Python, you can do something like name, and you can say name equals through, and you can go ahead and pass that variable name into a function, and in that case, you can say print through, and I can go ahead and do something like this. Um, I can go ahead and do something like print name here. All right. I don't even need that name there. I can say, hey, a function is going to take a variable name and it's going to go ahead and print that name through. So now when I call the function, I give it name and it should print name through. So we are very comfortable doing something like this in Python. But here's where it gets interesting in the world of functional programming. Let's zoom in a little bit more so the screen is visible. So here's where it gets interesting in functional programming. Just like the way we can pass variables, so this is a variable, just like the way we can pass variables to functions or assign variables or assign values to variables, we can assign functions to variables. So I can go ahead and say, hey, let's just control Z this for a little bit. So I can go and say, let's just have this basic function here. And that function is going to print hello through. And instead of calling that function directly, here's what we can do. We can create a variable called hello. Let's just call it tech. And what are we going to assign to that variable? We're going to assign hello through. Now, what is hello through? Hello through is a function. So we're not just assigning values to variables. We can actually assign functions to variables. And now, if I go ahead and I say hello tech, guess what happens? Now, this variable is this function. So if I invoke this variable by this double bracket, guess what's going to give us? It's going to print us greetings from through. So this is one new concept we've already run into when working with functional programming. So functions are first-class citizens. You can assign them almost like primitives, almost like the way you assign values to integers, to strings, and all of that. You can assign functions to variables and pass functions between to other functions, which are things we're going to see here shortly. So the first concept we've seen is you can take a function, assign it as a variable, and then call that function. Now, the next thing we're going to see here is once we've assigned that function to a variable, we can do a couple of things. All right. So we can say, hey, I'm not going to go ahead and invoke that function. Let's just try something here really quick. So let's just do a print, and I'm going to print my name on the screen. So I'm just going to print through. All right. Something very simple we do, we can print through. Now, what happens if we print not just through, what happens if we print hello tech? Okay, so just think about this as, let's say, uh, let's just do this. Let's create a variable called name, and we set name to through. All right, and I come in here and I can print name. So similar thing that we did before. Let's just see what this does. So I come in here and I'm printing name. So name has been printed. Okay, so what does that give us? It gives us through. All right, so we have a variable set to name, which is a string, and we're printing that. What happens when we print not just the name, now we're printing this function that we assigned from above, right? So what happens when we print hello tech? Guess what's going to happen? It's going to print the function, but it's going to be binary, but it still prints the function for us. So there is a function in there that's getting printed, okay? It doesn't make a lot of sense to print the function, but just to tell you that there is something in that place that can do work for us. All right. Now, what we've seen here is we can take functions and assign to variables and print them out, But we can also take them and work and pass functions or hold functions in data structures. So let's say we have a dictionary or a tuple or any data structure you're working with. All right, we're gonna just create a quick dictionary here to hold a couple of values. So let's just create a dictionary to hold a couple of values. So the first value here will be true, and the lookup there would be one. So dictionary almost like a key value pair. Let's do tech, and the lookup there is two. And then we do the next thing here. I'm gonna do something interesting here. We're gonna do hello through, and the lookup is 3. Now you might say, what is hello through? Okay, just hang on to that. So here we have through, the value is 1. Take 2. Well, hello through is what? It's a function. It's a function that we define. So we can actually put a function almost like a data into a dictionary with a lookup value. All right. So if I come in here now and I do something like print, we want to print something from the name list. You want to print something from that name list. Let's print from that name list. Let's just 1 second here to make sure that we're all set. All right, so let's do this. Let's print from name list, and we are going to print what we have as we're gonna print what we have as a through. All right, in that list. So let's see, what do we get? Let's comment this all out so we get clearer screen. Let's delete this. All right, let's delete all of this from above. Right, so I'm creating a list with a dictionary key value pair, and I'm printing from that list through. What do we get? We get 1. All right, so let's print that again. So we get 1. All right, that makes sense. We can also say, hey, what is in that function? What is in this value of this function? And we should get 3. All right, so a function is treated as something you can create, pass to variables, send to functions. It becomes a lot more than what we are typically used to functions, right? You don't just call a function the way we used to call it in procedural programming. Now you can actually pass function as variables and do a lot more with functions than before. And this is where functional programming gets really interesting. All right. So we've seen the basic functions, passing functions as variables, setting functions to variables, and setting functions to data types. We can even take functions and pass to other functions, which is something that's interesting. All right. So what we're gonna do here is, let's just clean everything on the screen, define a quick function really quick here, and we're going to call that function through. And what is through going to do is going to print through. Let's just make it print um, through tech. Okay, we have a function that just prints through tech. And what I'm going to do next is define another function, and this function will just be tech. And what is it going to take? It's going to take some variable, and I'm going to call this variable function. All right. And so watch what happens. So this variable I'm calling here function. Well, if it's a function, what can we do with a function? We can invoke a function. I can say something like this. So give me something, whatever that is, it's going to be a function, and I can invoke that function. All right. So let's see what happens here. So if I go down now and I do something like, let's just go back down here and see what happens. So if I go and I want to call this function take, okay, I have to pass it something. Well, what can I pass it? I can pass it, it takes a function, right? If I pass it through, it's not going to work because what it expects is a function. So if I give it a function, and what function do we have? We have a function here called through, the one above. All right. So tech is a function, and we're going to pass it another function through. And guess what happens? It's going to take through and it's going to call that function. All right. And what's the result going to be? I want you to guess what the result will be. Okay. So if I call the function through, which is being called in here, what is it going to do? It's going to print us through tech. All right. So if you go ahead and run this, and there we go. It's printing us through tech here. Now, this is another new concept we're seeing. You can start creating functions, setting functions to variables, taking a function and passing it to another function to do something. And it opens the door for a lot of exciting things, which we're going to see a little bit later on. Because some of these foundations I like. All right, why do we have to take a function and pass to a function? Why don't we just invoke the function by itself? But just hang on there for a second, right? Because we're going to explain why this becomes really interesting with functional programming. Okay. Now, if we can pass functions to other functions, we can equally return functions from functions. All right. So return values or return functions from functions. We can do that. We can do that. And we're going to see how to do that here shortly. So we can again define a function. Let's just do a function called through. All right. And inside of through, we're going to define another function called take. Now, inside of take, this function we've defined, we're going to print something on the screen. All right. What do we print on the screen? Something. All right. All right. Let's just do subscribe, please. Or subscribe to through take. All right. That would be awesome, right? If we all do that. All right. So let's just print subscribe to through take. And we're doing that inside of this function. All right. So one function, and then we have another function inside here. All right. But because this is a function inside of here, guess what we can do? We can come now and say, hey, let's return something, right? So let's return something from this function going back. But what do we want to return? We want to return, and we're going to return take. Okay. We don't need that. So we're just going to go ahead and return take. Now, we're gonna run through this so you see exactly what's happening. So we've defined one function. Inside of the function, we define another function, and in returning from this function, we're gonna return the internal function. So whenever you call this, your return result will be this function. All right. So how can we invoke this? How can we work with this? All right. So normally we can do something like through. All right. If we've defined a function, we can call that function through. Right. So if I call the function through, what's gonna happen? It's gonna return something. Okay. We don't see any results here. Why? Because we're returning a function. Now, if the result of what we are getting is a function, then we can call that function. So we can call the function. All right. And now if we do that, then we should print this inner statement. Okay. Now we can go subscribe to through. So a function can return functions, and you can then do something with that function. All right. So this is one way of doing it. Another way of doing it would be, and I think this would be more intuitive to folks, would be doing something like having a variable called through-text, or you can say return value. Let's just do return value, all right, from the function. And that return value would call this function through. So when we call this function, it's going to return something to this return value, all right? And we can just run this. And it's return something to this return value. But we can do something to this return value because it's another function. So we can do something like return value, but because it's a function, we want to invoke that function. All right. And if we invoke this function that we've gotten, now we get again subscribe to through-text. It's just exactly the same thing that we did before. All right. So this two statement is exactly the same as doing something like through function and then call whatever the result was. Right. So doing those two things is exactly the same. Subscribe to through. All right. Really exciting. We've touched on some things. Now let's clean this up and go into another concept that tends to be very relevant in functional programming, which is Lambda and anonymous functions, if I can spell. Right. So Lambda and anonymous functions. All right. So let's do a very simple example. And Lambda is an interesting concept to deal with when it comes to functional programming because people get worried about lambdas. Is Amazon Lambda? What lambda are we talking about? To put it simple, a lambda is just a way of defining a function in this format. It takes a parameter list and an expression to apply to whatever you've put in the parameter list. All right, so let's actually look at some examples here. I'm going to do a quick example. So I want to have a function that takes a number and add 1 to that number. So that's what we're going to do. The function takes a number and is going to add 1 to that number. So the way we're going to do that with lambda is we're going to say lambda, following that syntax from above, a function would take a number. So let's just call that number x, and so the parameter, this is it. This is what's coming. What do we want to do with that parameter? We're going to take that parameter x and we're going to add 1 to it. So this is our function. All right. This is what lambda does. So if I go ahead and run this, nothing happens. All I've done here is simply define a function. Okay. Now, with functional programming, we know we can assign functions to variables from above, right? So we can define a variable called add1, and add1 would be this. Okay. So add1 is a function that takes a value x and adds 1 to it. Now, what can we do with add1? We can call add1. Think about it as just another function. So add1, and we should get 2. All right, well, unless we have to print something out, so we can get 2. So let's go ahead and print that out. So we can get 2. All right, so if I put in 100 here, we should get 101. All right, so this is at the very fundamental level. This is what a lambda is, or anonymous function is. So you define the anonymous function, you assign it to a variable, and you can invoke it like any other function. Okay. Now this is a function that adds 1. Let's do another function here that maybe does an average. So we want to take a bunch of numbers and we want to average them. All right. So again, the syntax would be lambda, and following the syntax, parameter list and expression. So what's a parameter list? A bunch of numbers. So let's just call the numbers A, B, C. All right, so we're going to take 3 numbers and we're going to do the average. I don't know if this is correct, but I'm going to try something here. So A plus B plus C. All right, so we add it and we divide by 3, right, to be the average. Right. Hopefully this is correct for all the math geeks out there. If this is not the way of doing average, let me know. But all right, so we're gonna take 3 numbers in the parameter list, and we're gonna add it all, divide by 3 to give us the average. So this is our anonymous function. But to invoke this function, let's set it to a variable, right? Or let's set it to a variable or give it a name. The correct term is you're setting it to a variable. So now we have a variable or a function which is average, and as before, we can go ahead and print something like average. And in that case, now we can give it 3 numbers and it's going to give us the average. So let's do 3, 4, 5. All right. And if we do something like that, it's going to give us the average, which is 4. Throw 400, and the average for that would give us 136. All right. So we can now create functions, and they call this sometimes throwaway functions. Set those as variables and then call them on demand. All right. So really cool. And whatever values we give here, here in whatever values we give, it does something and returns a result for us. But we don't always have to do something, right? You can do something like, let's just say static. And there's not a lot of reasons why you do this, but you can do something as simple as age equals to lambda, and there is nothing in the parameter list, but you just want to return age as 109. I don't know why I'm giving age as 109, but that's just what I'm going to do. So 109, we just give age as that. All right. And if I go ahead and print age, it would just, well, I need to call a function. So if I go ahead and print age, it would just print 109 as such. All right. So you can actually use, it's almost like setting a static value to age and then just printing that. All right. There might be reasons why you do this, but I thought I'll just bring this up for folks that um, that find this relevant. Another thing that you can do too is maybe work with iterables or with like tuples. All right, so you can also return tuples from functions. So you can do something like, let's say you're working with a list of birthdays from for your friends. You're gonna define a lambda, and that lambda is gonna take um, birthday. Let's call that A, and it's gonna add numbers to it to give you key birthdays that you really should celebrate. All right. So let's say if you give me your age, I'm going to tell you the key birthdays that you want to celebrate. And I want to return that back as a list. So functions can return lists. They don't just return scalar values, they can also return lists. Okay. So now we could do something like A, return your age A. We can return A plus 10. We can return A plus 20, A plus 30, and you can just keep going on, right? You can do A plus 40, and we can return a list from a function. But if I run this, it will be a problem, all right? So we're gonna have to return a list. So we wanna put this all in a bracket. So now we can do something like print birthdays, and in there, because it's expecting this initial parameter from the parameter list, let's do age 50, right? And if we run this, now it's going to print 50, 50 plus 10, 60 plus 20, 70, 80, 90, right? So Lambda functions don't just return static or scalar values. They can actually return lists um, as well. All right. So another key thing we've seen in functions. Now, let's switch gears here and then take a concept that we might do in declarate in procedural programming, and I'm going to show how we do it, and then that will lead us into some key things in functional programming like maps and filters and uh, and lists, which are really key. These are foundational when it comes to functional programming. All right, so yeah, so in here we're gonna work with iterables. All right, what are iterables? Iterables are, let's just get a list of numbers, and we want to iterate through the numbers here. So let's just get a list of 1, 2, 3, 4, 5, 6. So we have a number. It could be a list you've gotten from a table, a data frame, or whatever it is you're working with. Let's just get a very simple list here to start with. All right. Now we have our list, and we are ready to go. What we want to do in this list is we might want to do something like find all the even numbers in this list. Or you might say, hey, not just finding even numbers, you might want to take each list and then multiply by 2. All right. So let's actually start with that example. Let's start with taking this list that we have on our screen here and multiply each number by 2. Let's write a function for that. So if you ask the average person that doesn't do functional programming, that does procedural programming, how to achieve something like that, how could we do that? There are many ways that we can do it. But one way could be to iterate over that list. And this is where iterables come into play. So let's iterate over that list using a for loop, right? So we're going to say something like for norms in norms as an example. So for we'll just give a placeholder here in for every value in here, what we're going to do is let's just print since we're multiplying by 2, let's just print num times 2 as a result, right? And we're gonna end it uh, when we see when we see something like this. All right. So in procedural programming, we can do something like this. You can see the result here on the screen. I don't know if you can see our result. Let me zoom in the results too, so we can see the results when we print. So we have a list 1, 2, 3, 4, 5, 6, and we're basically iterating through that list. So we're iterating for each list. So it's gonna take 1 times 2 and put it 2 times 2 4 and put it 3 times 2 6 and put it. We're iterating one by one by one by one by one. All right. This is the procedural way of doing things using for loop, while loop, do while loop, whatever it is you're using. This is how you do it in the old in the procedural way. I wouldn't call it old fashioned. I almost call it old fashioned. All right. Let's see how we can do something like this using functional programming and using all the building blocks we talked from above earlier in this lecture. All right. So, what do we want? We want to double numbers. All right. So, let's write a lambda that can do that for us. All right. So, we're going to write a lambda, and we know how to write lambda as we saw a little bit earlier. A lambda can take a value x and it can double that value times 2. All right. So, this would be a lambda that we can write. All right. Good. So, we have a lambda. Now, how do we call this lambda? I can just put this to a variable and call it. We've already seen how to do that. But I want to introduce one other function here, which is part of the library for functional programming, which is map. Okay. And a map is something that takes a function. Well, it doesn't take, yeah, let me put it that way. It takes a function. So here you give it a function and you give it a list or you give it some iterable, and it's gonna loop through and apply that every item in that iterable to that function. All right. So this is where functional programming really becomes cool. And let's see how this will all work. So if I go ahead and I say, let's just call this double it. I think we saw that we can create a lambda expression and give it a name. Now we can now say double it. Bear with me if I can type double it, and then we'll give it an iterable. Well, what is our iterable? Our iterable would be nums, which is our list from above, right? Nums. So we have this list and we want to double it. So what map does is it's going to iterate through this list for us. It's going to iterate almost like a for loop built into it. It's going to take one and it's going to send one to this function and it's going to double it. Then it goes through the next thing on this list. Let me zoom in here for a second. All right. So it's gonna take one. This, and let's actually just go ahead and delete this because we don't need the procedural stuff. So what this will do, a map will take this list and it's gonna iterate through. It's gonna take one and it's gonna send one to this function. Well, what's gonna happen? This function will double it. It's gonna take that one and double it, and it's gonna go through every value. It's gonna iterate through every value in this list. That's what map is gonna do for us. All right. So we can actually go ahead and run this, but nothing is happening. You might say, well, why is nothing happening? Well, nothing is happening because map is going to return a list for us, right? Because as it iterates through, the result will be a list, which we want to capture into a list. And if we run this, we're going to have a list. But again, nothing is happening to that list. So we can go ahead and print that list to see what is in there. All right. So at this point, we should see 2, 4, 6, 8, 10, 12, which is a double of this list. That's basically what a map does for us. It takes a list or it takes some value, some list of values and a function, and it iterates through every single item in that function, apply it to it, to that, and send it to this function, and the result comes back. All right. What we've done here, if you don't want to make this verbose, it's exactly the same as taking this function instead of giving it to a variable and just directly placing that function in here. All right, you can do something like this. And if I comment this out, and we run this, it's giving us exactly the same result. To prove that this is actually running, change that to 10. You can see 20, right? So this is actually running. Now, we can do something like this with map. Functions. And the reason is now we are treating functions as a first class citizen that can take values, execute on them, and run. You might say, but this is a little bit complicated, because I understand. I appreciate for folks looking at this and saying, why do we have to go through all of this pain? Imagine if you had a for loop and you had millions of record in a table. You wanted to apply a function to each item in that each row in that table, and you're going for 1, 2, 3, 4, 5. It just takes forever, right? But a functional programming, you're just applying the function to your set. A lot simpler intuitively. If you get it, it just becomes a lot simpler, right? I don't really know how to put this any better. All right. So this is what a functional programming, a map would do. A map would do for us. And if you get this whole idea, you've gotten a majority, a big part of functional programming. This is really about it. All right. We can define a function that takes a value x, does something to that value x. Then we can take a list and pass it to that function. If you can't understand this, just understand this one, right? Where we've defined a function, a lambda, takes x and and doubles that number, multiplies it by 2. Once we have it, we can take that function. So we're passing that function to a variable, and in the map you give it a function and some values, some lists, some iterables, something to do with it, and it simply goes through every single thing in that list and gives you a result. We put that result in a list and we print it out. That's what we've done here. All right. Now, let's look at another example working with iterables, a problem that we might want to solve and hopefully this second example would uh, really build us our confidence working with functional programming. So, in the second example, we're still going to keep our list, nums. And somebody might say, hey, take this list and find all the even numbers in this list. Again, that's something that we might have to do in procedural programming, and it will require a while loop, right? So for num, something like this in nums, right? You might say, let's put a conditional in here, if num and percent, something like this, to check is it mod 2, is it 0? And if it's 0, then we go ahead and print that, right? So something that 101, every programmer uh, would be required to do. And if we run through this, it should be able to take the numbers and print out just the ones that are even. So if we run this, sure, we get 246. So 246 are the even ones in that list. All right. But again, this is procedural. We're giving you the procedure on what to do. But we don't want that. We want to define a function, a pure function. And the reason why I said at the beginning we're not going to touch about pure function, monads, and all of that was because that will be a separate video. That will be a separate presentation. But we define a function and then we apply, we're doing a more declarative way. So instead of doing this looping and all of that, let's see how we can do this in functional programming. All right. In functional programming, we're going to use another function here, which is very common in functional programming. Not just the map, but we're going to use something called filter. All right. But before we do that, let's define our function. Right. So let's do a lambda. And what is this lambda going to do? It's going to take some number x. And what do we want? We want it to take that x and mod the x by 2, and then check if it's 0. All right. So that's what a lambda is going to do for us. It's going to take some value, mod it by 2, and check that if the result is 0. Now let's give check even. So let's give it a name to this function called check even. Right. So it's just a function. Give it a number, check mod by 2, and check if it's even. All right. Now we want to apply this function to this list, right? We want to apply that function to the list. So we could do map. We can do something like map check even and give it nums. We can do something like map check even and give it nums. But as we saw before, it's going to return a list for us. And if we want to actually see that list, we have to go ahead and print that list. Do I have enough brackets? Yep. We're gonna go ahead and print that list. All right. So um yes, what we have what we have going on. Okay. So we have map. Well, I think we're missing something here. Let's go ahead and list. I think that's what I was missing. So if you go ahead and run this. Okay. So this is interesting. And we're gonna build. I know I talked about using filters, so let's do filters here. But you might say, before you're talking about filters, why are we doing map here? I just want to build to that so we see what's happening. All right. So we have on a list of numbers here. We've defined a function that takes a value x multiplied by 2 and tell us if it's mod 2. So if it's mod 2, it's gonna tell us true. If it's not mod 2, it'll tell us false. Right. So true or false, true or false, true or false. That's what we're getting. But we don't just want to get true or false, true or false, true or false. We want to get the actual values that are here. If it's true, we want to get this. If it's false, we don't want to get that value. All right. And that's where filters come into play. All right. So I'm just going to go ahead and comment this out. So instead of doing map, again, what we're going to do now is we're going to do filter. And filter is going to take a function called check even. It's going to take some numbers and it would apply that every number, iterate through, apply everything in this list to our function. And if the result is true, it brings the value back. All right. If the result is not true, it doesn't bring that value. So filter is a little bit confusing. It's not filtering the results that are true, it keeps the results that are true. All right. So now if we do something like list, let's list this everything here. So we do something like list, right? And we print it out on the screen. And we print it out on the screen. So what do we get? We get 246. All right. And this is where filter come into play. So we're taking our function and a list of values, we're applying each value into that. And filter would filter the things that will keep the things that are true, and the things that are not true, it would send them away. Right. And the result is we get back our values. Now, again, as we saw a little bit earlier, when you get more comfortable with this, you can just directly take your function, replace this variable here, and we have exactly the same thing. For the average beginner, reading this is a very intimidating. Even myself, I'm not a fan of writing things like this. But you might run across code like this, but it all makes sense. Again, we have filter, we're giving it a function and a list of values. It iterates through those values, send it to a function. What does the function do? It takes a value and check if it's even, and if it's even, true. Well, if it's true, it gets kept. If it's not true, it's filtered out. And we take the result, put it in a list, and we print it out. And we run this, we get exactly the same thing. To prove that this is correct, we put that as 10. We run this, we get that, right? 10, 2, 4, 6, even numbers are kept. All right. So really good. We've seen two key concepts here. We've seen filters, we've seen maps, and we've seen how to create functions and put them as variables and how to pass that. All right. Let's look at another one, which is you might run across often, which is reduce here. And we're gonna keep our list. So another problem we might run into is you have a list and we want to calculate the average of this list. So you have a list. Tell me what the average of this list is. Take every number, sum it up, and divide it to give me the average. So how can we solve this? Using procedural programming, we can do something like sum, or just sum it. We don't even need to care about average. Just sum this. So we can do something like sum, and then we get a list, right? Just call the list L there. So we're gonna take a list and let's just create total here, and we're gonna set that total to start as 0. All right, and then what we're gonna do is we're gonna just iterate through list, and if in that list we're gonna just take total and just do total equals to total plus plus value, right? So something that is very common to do. And once we're done with that, let's go ahead and return total, because at this point we should get we should have total, right? So we can go ahead and return total. Now, very common thing we might have to do in procedure in functional programming. Will never This is not never allowed, right? You can have variables that are mutable, or they all have to be immutable, but that's for a different presentation. So procedural programming, we're telling the procedure on how to do this. If we want to test this out, we can call this function called sum and give it nums for it to sum it for us. So we can call it sum, give it a nums for it to sum it. Nothing happens. Why? Because we need to print out that result. All right. So let's go ahead and print out the result. So if we print this out, 21. So the sum of all these values is 21. To prove that, let's add 110 there. As an example, we get 30. All right. So the procedural way would be something like this. And I'm sure you're guessing already. Through, you're going to make us do this in functional programming. And if that was your guess, you're right, because we're going to have to see how we do this in functional programming. Again, what do we have to do in functional programming? We're going to introduce a new function here, but the building block is the same, right? Let's just start with a lambda. Lambda is kind of the pure function that we're going to be working with a lot. And pure function is something that can cover in a different presentation. So let's create a lambda. And what's the lambda going to do? It's going to take two values, x and y, or a and b, all right, or ab, anything you want, all right? These are just names. So x, y, give me two values. And what am I going to do with those two values? I'm going to sum them. I'm going to do x plus y, all right? That's it. Boom, that's it. Very simple lambda. But of course, let's give a name to our lambda. I always like to make sure that we take a lambda and we give it names. So let's just give a name is like let's say at, right? So let's just call a lambda at. So it's going to take two values and it's going to add it. Okay. If we call this lambda, we can actually, let's just do this. Uh let's print at, and it's going to take two values. So this lambda needs two values. So let's add 2, 4, right? It should give us 6. Very basic to test a lambda. All right. Now, what we're going to do is see how we can take advantage of reduce here. So now this is what we're introducing reduce, where we are going to use reduce. So use reduce. And what does reduce do? It's going to take a function, all right? And the function is what? At. And it's going to take some values, and it's going to reduce that. Now, you might see reduce is not showing up. It's showing up here with an error. So I'm going to have to import the function, import function to reduce. So if you see this error, you're going to have to do import function to reduce, which imports this. There is some philosophical debate back and forth in the community on why reduce is not part of native Python, and it had to be a library that you have to import. There are some thought leaders in the community that thought reduce is a terrible function to have. There is tons of videos about that, and articles have been written. I'm not going to touch on that area, but if you, for some reason, you have a use case where reduce is what you want to use, like what we're doing here, calculate average or calculate sum, um, then definitely go for it, right? And while at this, let me just actually touch on that, right? Because the reason why there's that debate on reduce is people might be like, why go all through this work when you can just do something like sum nums or something like that, right? And there are building functions in Python for you to do that. So yes, you can do it in other ways, but our goal here is to understand functional programming. There might be a case where this becomes handy to you. So because we're showing this doesn't mean this is the only way you can sum on a list of numbers. All right, so that's it. Let's go back to reduce. We have reduce. We're going to take a function which is add and a list. So what reduce does is it's hard to do this without drawing, but conceptually it's going to iterate through this list and add. So it's going to take this, add this. So take the first two, send it to this function, add it. Take this, next two, send it to a function, add it. Take this, send it to a function, add it. Now, the result of this would be added to the result of this. So then it's either the result of this gets added to the result of this, and that result gets added to the result of that. So it's basically reducing it until it gets a single scalar value. That's what reduce does. All right. Hopefully you get the point. So now, what are we going to do with reduce? So we're doing taking our list of values and the function that we want to apply to, and we're going to reduce it. Okay. But and if we want to actually test this, we have to print this out, right? We're going to have to print out this result. And if we do this, it's going to reduce it to 30. So if I do 100, if I do 10 there, it should be about 120. All right, so that's the result. You might have noticed I did not put list around here. Why didn't we put list as we did for map and as we did for filter? Well, because reduce doesn't return a list. It returns a single scalar value. So having a list there is not relevant, but we can still print that result. All right. And as we saw before, doing this is the same as just taking that anonymous function or that throwaway function and putting that in here. And it's exactly the same thing. It's a little bit harder of a code to read, but exactly the same thing we've done. Now, there are more things that we can do here from a functional programming perspective, like passing. Let me go back to this, like passing multiple iterators to a function. So you can have a list of different lists of numbers or values you want to work with, right? So this could be 200 or 700, and we can call this list 2, and this will be list 1. All right. We can do something like um, we can now go ahead and define a lambda. So let's just touch on this concept really quick. So we can do something like double. Let's just take these numbers, double them, and we're going to do a lambda here, which would take x, and it's going to take x uh, times 2. All right. A very simple lambda. Now we can map that, and in our map, we're going to double. We're going to give it a function double. And what are we going to give? We're going to give it nums 1. All right. But we can also give it nums 2, nums 3. So we can send multiple iterators to a function, and we can throw that into a list. We can throw that into a list, and then we can go ahead and print it out. Okay. So there are a lot more things that we can do. Here. In this. And so you might have an array, you might have a data frame coming, or a data set coming from a table in SQL. If you're doing Spark or you're working with Snowflake Python function, you can create all these functions and apply those functions to the data that you have, right? Which is what Snowflake for Python and Spark and a lot of folks allow you to do. But hopefully, this is giving you some ideas in terms of functional programming. Just to kind of recap what we've seen here, we've touched a lot of concepts. So I'm going to clean up the screen. Yeah, we've seen what is functional programming. It's not a new tool. It's not anything new. It's just a way of writing program using functions. Now, some new concepts have been introduced, like first-class citizen, where you can take functions and assign them to variables and pass functions to other functions, return functions from other functions, which is really cool. Now, the moment you can pass functions to other functions and return functions from other functions, now we introduce the whole idea of lambda, which are throwaway functions, or they call them inline functions. You can define lambdas. Now, a combination of lambdas, now you can use map to take iteratables and send them to functions. Or you might say take functions and send them to iteratables. I think it's the other way around, and get results. So you can take a list or a dictionary of items, or actually a list of items. If you're working with databases, this could be thousands and thousands of customers lists from your database, and you want to do their credit score, right? You might have a function that checks for credit score and returns a value. Now you take a map of that function and give it a list of your customers, and you get a result, right? So it just allows you to be more declarative in terms of what you want versus a procedural way, which is writing for loops and while loops and all of that. And then we saw filters, which returns result if boolean is true and doesn't return the result if it's false. And we also saw reduce, which is kind of an iffy one. The community doesn't seem to like it that much. You have to import it but you can use reduce to do like average it, or to do like sums, an aggregated type of function, and it returns a single value, reducing it as a whole. So really cool. As the next step or takeaway, and things we didn't touch about in here, because functional programming is a huge concept. To become proficient at this, we've only scratched the surface, right? There are things like monads. If you want to get really excited and you cannot sleep, you just want to occupy your mind, or recommend you go read about monads or true functions, or even category theory in mathematics, which is a foundation for functional programming. You're gonna get a lot of things that can takes your understanding of this to the next level. All right, guys. So there you have it. Hopefully, this has given you some good, warm introduction to functional programming. Watch it as often as you can. Play with it. Try your own examples. Create functions to solve problems that you have. The more you play with it, I think the more it becomes more second nature. And if you can take a functional code and even read it and understand what's going on, I think that would be a big win. For me, one of my motivations for this was when I was running into functional programming code, I just couldn't understand what was going on. And it took a while for me to be able to understand the syntax, right? But once you understand it, I think it becomes very, very comfortable to play with. All right. Again, thanks as always. I'm going to leave some links in the description below. Check them out. I'm going to leave a book, which I think is a very good book on functional programming that touches on some more deeper theoretical concepts if you want to go to that level. But if you have any questions, don't hesitate to let me know in the comment section below. I'll see what I can do. You have been very awesome watching to the end. I have been through, and I will see you in our next lecture.